Good evening and welcome to Dylan Academy. Today we are going to be working on a topic that is close to my heart and that I quite enjoy. So let's get set up. That topic that we will be working on is testing the difference. Let's write this out for you. Testing the difference between two means of independent samples using one of my favorite tests, using the t-test, which is just awesome. Alrighty, so here we go. You'll note that in the last section, we used the z-test to test the difference between two means when the population standard deviations were known. However, this actually rarely happens in statistics. It's much more likely that we won't know the population standard deviation at all. What changes in this test, you might ask, is that as long as the variances are assumed to be unequal, not a lot. So there are a couple requirements for testing the difference between two independent means using the t-test. I'll write them out for you so you can get a look. So the first is that both samples are random samples. Also, the samples must be independent. Good, just like so. And in other words, there are no relationships between the subjects of each sample. And third, if the sample size is less than 30, we must have a normal distribution. If the sample size is less than 30, we must have, whoopsies, a normal distribution. Sorry about the messy handwriting. Trying to get all the information down on this iPad. All right. So, given that the population variances are assumed to be unequal, the test value will be this. Let me write it out for you. T is mean 1 minus mean 2 minus mu 1 minus mu 2 over the square root of your first sigma over your first sample size, so n1, plus your second sample squared over your second sample size, just like that. So I'll just pause and enjoy that. And it's important to note that where the degrees of freedom can be found on your calculator in Statsal's Editor F6 for two-sample t-test, and then you got to change it to stats, you can just put in your given information. But if you go straight to your inverse t, or to TCDF from there, the degrees of freedom will automatically be put in for you. So that last equation was for our test value, but we also have to find our degrees of freedom. So again, assuming the population variances are assumed to be unequal, we ask what the confidence interval for the situation would be, and you want to find degrees of freedom, and it would be found like so. Just like the problem that we had before, or the equation that we had before. We're going to take our, switch that up. We're going to take our x, the mean, the first mean, minus the second mean, minus our test value over 2, times the square root of that same thing, our sigma 1 squared plus sigma 2 squared. That sigma 1 squared is over our n1, and sigma 2 squared is over our n2. Then we're looking for if it's going to be less than or fit into mu 1 minus mu 2. And then the same thing is just repeated on the bottom. So we'll have our x1 minus x2, those. But then the difference here is that this has to be a plus. So you have your plus the value on this side because it's positive. And then again, times the sigma 1 squared over n1 plus the sigma 2 squared over n2. So it would be in a straight line, but because of the space that we have, we just have to kind of stack it a little bit. So there you go. You can take a look at that. Alrighty, so now we're going to get into our problem. I'm going to give a little example problem to try and show you how to do what I'm attempting to show you to do. So let's start with this one. We're going to say, or rather we're going to ask, do employees perform differently at work? We can just leave that with a diff, you know what I'm talking about. Differently at work with music playing. An interesting question to ask, as people will ask whether you can study with music playing or read with music playing. It all depends, but this is just for this particular study. That's also a question mark. And so our first sample is saying that the music was turned on during the work hours of a business with 45 employees. So turned on, 45 employees. So we know already that that is going to be our first n, that's our first sample size. But we also know that it's going to be split up. So we can find out that from this study, they find out that, let's retry that, that their productivity level, or the task they completed in an hour, averaged 5.2, so that's where we're first going to get our x, 5.2, with a sample standard deviation, we'll just go SD, of 2.4. So there we go, right there we have our first sample, but because this is a two-sample t-test, we're finding the two independent means of two different samples, you know, there's going to be two samples. So on the second day, we can say that on a different day, just on any day, the music was turned off, and there was 40 workers. So no music, 40 workers, or employees, however you want to say it. So that's going to be your second N, your N2 is going to be 40. So on that day, their productivity level, they averaged 4.8 with a standard deviation of 1.2. So our question is, can we conclude that the productivity level is different at the 0.5 level? So that'll give us our alpha, 0.05 level. And we're assuming the population variances are unequal, and we're going to use a confidence interval to solve. Alrighty, so with our problem, it's safe to say that we can write out what we know. So we know that our first mean is 5.2. Our second mean is 4.8. Our first sample size, N1, is 45. That was from the first day. And our second sample size, or N2, was 40. That was for the second day. We also know that our sigma is 2.4 for the first day, and for the second day, it's 1.2. So a super easy way to go about this is just to go into your calculator, to find F6 in the StatsList editor, click on two-sample t-test, switch the data input method to stats, and then just fill in your data. It has it all there for you. So you're just going to take what you know here and just pop it into your calculator, just like so. So we can all do that on our calculators together. Beautiful. And after you type that in, you're going to find that your p-value equals 0.837, and your degrees of freedom is 66.31. After you've done this, you'll also want to check on the inverse t, but we can do that in a second. So after this, we'll state our hypothesis, which we know our ho is going to be mu1 is equal to mu2. This is what we're trying to find out. And our ha is saying that it's not going to be equal. So it does not equal the mean 2. So after we have this information to start, we want to draw our curve. We want to see what this comes out to be. So if we have our curve, we know it's two-sample, two-tailed. Beautiful, beautiful, just like that. And if we go into our inverse t on our calculators, well, you just go F5 inverse t, and you can plug in, here, let's just go there really quick. I'll just click on that all together. Beautiful. It'll ask you for the area and the degrees of freedom. So if you know your first area is that 0.025 because you have the 0.05 divided by 2 because there's 2, so that brings you to this. And then you know that your degrees of freedom, like we already found, is that 66.31. So you can plug that in and find out that, let's do that, 0.025 and 66.31. And you can find that it's going to come out to about 1.996. And this is negative because it's on the left, so 1.996, just like that. So there you go. There you have your curve. So now we have our next part, which is actually filling into the equation and seeing if it's greater than or less than to the mu1 equals mu2. Alrighty, so now we will go about plugging this into our equation. So we can start by taking that first mean. If you remember our first equation that we wrote, we have our first mean minus our second mean, the first day minus second day, minus, we're going to minus that test value, 1.996 that we have, and then we're going to multiply it by the square root of that s1 squared over n1, so we can put in safely 2.4 squared over 45 plus 1.2 squared over 40. There we go, just like that. And then we know that we have, this is what we're testing, minus that mu2, that mu1 minus mu2, just like that. And then it's basically just repeated, except we just can't forget to put the plus in instead of the minus. So again, we're going to have 5.2 minus 4.8. And then we're going to go plus that test value, that 1.996. And then times again the same thing, the 2.4 squared over 45 plus the 1.2 squared over 40. And then we just got to solve that. So once we solve that out, we'll find that we get negative 0.0408 is less than that mu1 minus mu2, which is less than the upper value, or not the upper value, but the higher value, 1.208. So from this, we can conclude that we do not reject. We're not rejecting the hoe. Just like that. Do not reject. Do not reject that hoe. So then, and our final summary is that we can say that there is not enough evidence, at least in this problem, not enough evidence to claim, oopsies, that music has any effect on the workers at all. Has any effect on the workers. So there you go. You have now successfully completed and successfully tested the difference between two means of independent samples using the tease test. So good work. Proud of you, and subscribe to my other videos if you want to do more stats sometime. Alrighty, we out.